start.
Hello, I'm Michelle Davis of the Center for Manufacturing Research at Tennessee Tech University in Cookeville, Tennessee. Welcome to the Spring 2021 Golden Eagle Additively Innovative Virtual Lecture Series. This is the 11th semester we have produced this popular and informative series. The series is hosted by Tennessee Tech's Center for Manufacturing Research and the iMaker space at TTU. Additive manufacturing is a focus of both entities, and as such, this short virtual lecture series has been planned to highlight the best practices, potential problems, technological advancements, innovations, and scientific contributions in additive manufacturing, with expert talks from various institutions, industries, R&D centers, and laboratories. Today, we are honored to hear from Dr. Jennifer Loy, Professor of Additive Manufacturing at Deakin University in Australia. Her talk is titled 3D Printing Product Development Decisions. She will provide her contact information for questions after the presentation is over. Thank you, and I turn the presentation over to Dr. Loy.
Thank you very much, Michelle, and it's very good to be here. I hope you're all staying warm. I hear the weather in Texas is very cold. It's not like that in Australia, but we do have the opposite problem in Melbourne, where we've had a bit of a heat wave, which can overload our power systems too. So the talk today, I'd like to talk about additive manufacturing really from a product design point of view, because that's my background. But I'm looking at it from that perspective, but also talking to CEOs, production development managers, and production managers to see what a product design development decision should look like in terms of additive manufacturing, or could look like, and sort of help understand where we can go from here. Essentially, I'll be covering three things. Why do additive manufacturing at all from a sort of bigger picture point of view? Why do it from a product design point of view? If you're a product designer like me, why is it worth doing, and what should we be actually doing? And then also why from a business perspective. And I'll give you some guidelines and starting points. I know it's a short talk, but really just to sort of how to evaluate a proposal. So as a product designer, we're often asked by a company to look at, should we be using additive manufacturing for end-use products? We've all been using it in rapid prototyping for many years, and that might be in terms of small desktop printers. It might be in terms of using online service providers. But should you, as a product designer, be recommending to a company that they commit to moving into end-use products? And if so, what might that look like? So the first question really is it worth doing? So essentially, my opinion is that if a product or part can be made using conventional manufacturing technology at this time, it should. If it can be made using conventional manufacturing technology. In other words, the only justification to me for using additive manufacturing is that it's exploiting the characteristics in additive manufacturing that add value sufficient to make the technology viable. It might change in the future. So production processes are maturing all the time and it's becoming far more economic. We're seeing essentially build farms evolving, and that's excellent. But really, unless it exploits the characteristics and opportunities of additive manufacturing, my opinion is stick to what you know. From a sort of more of a world perspective, essentially, why should we use additive manufacturing? Think of the 5 rights of logistics. You want the right product in the right place at the right time, at the right quantity and quality, and the right cost. 3D printing couldn't be more perfect from a business point of view in order to match that. If we think about the development cycle, and we're trying to sort of get things to market as quickly as possible, develop things iteratively with the market, alongside the market, 3D printing really will help you with that. Logistical postponement, so in terms of being able to ship material and then make product on site, that's a real advantage. And then the management of spare parts. From a a world point of view, if we think about some of the challenges that we're facing today, in terms of rethinking how we work as a society and how we use materials. I'm always particularly interested in work on the circular economy. Martin Charter in the UK is one of my heroes and the work that he's been doing there. But essentially, if you think about what the future of industry could look like with 3D printing, if we really went all in, if something happened that made us say, right, we actually have to sort of rethink our whole approach to products and our relationship with products, we could move from mass production to mass customization, invested design, and focus on product service systems, value adding, design for disassembly and production on demand. Again, 3D printing really is worth exploring as a society to sort of meet some of those needs. I obviously favor all the Australian researchers, and Chris Ryan's ideas on sustainability are ones that I think are really good drivers. So looking at this, decarbonisation and dematerialising the economy, if we're really genuinely trying to move towards that, then 3D printing should become ubiquitous as far as it possibly can, focusing on design, the design of products and product services for that kind of added value and maximizing resources. So that's kind of like the bigger picture stuff. So from a society point of view, I feel very strongly that we really should be looking far more seriously at the adoption of additive manufacturing, and it was certainly what got me into it in the first place. But how about for you as a product designer if you're working in industry now? Okay, as a starting point, I'm just being tortured by a fly here, which is an issue in Australia, so just ignore it. So as a starting point, when you're evaluating products, say you have a product design proposal, or say you're thinking about going into end-use products and you're thinking about the type of products that can be made, what starting points can you have? So I've got some here, and I'll run through examples essentially so that illustrate these things. You know, is it complex enough? Does it exploit design for additive manufacturing capabilities? Has it been detailed for additive manufacturing, which is a key point? Does it use things like customization or short-run capability? Will it change business practice? And what will be the impact on your business? The complexity thing is an interesting one. You know, I've been teaching design engineering, product design and industrial design, whatever you want to call it, for a long time. And when it comes to additive manufacturing, my challenge to students is always, you know, could it be made any other way? Don't show me something that's been made before in some other way. So you can see here just some examples. The one at the bottom, Dave Haggerty, is a first-year student, and then second-year student, Casey Fitzgerald, who actually went on to work with Materialize for a while in Malaysia, and now is doing her PhD in surgical guides, 3D printing surgical guides. You can see here what they're trying to do is demonstrate the kind of thing that you couldn't make any other way. And I think what's particularly lovely about this, I have to say, is that they were both done in SolidWorks, which is a challenge in itself. It's probably not the software we would use now. We're actually evolving our practice because of some of the different softwares that are coming out that are offering some really interesting possibilities. But I'd just like to show you that you can do really complex organic models using SolidWorks. So that shouldn't be an excuse. So this is the kind of product, for instance, a light that one of my PhD students, Elvira, produced. And if you're facing a product, if you're being given a product and you're asked, is this a good product in terms of additive manufacturing, in terms of design for 3D printing, one of the things you can look for is, again, that complex geometries. Could it be made any other way? Is it exploiting the ability to make complex geometries that you couldn't do with, say, injection molding? And this is a really nice example of that. Another characteristics you might decide you want to exploit is the fact that you can create assemblies as a single part, which is an astonishing capability, and we'll touch on that a bit later on more when it comes to sort of business practice and what that actually means. But here's a fantastic illustrative example. It's a PhD student of mine, Sam Canning, who did this unusual hat, which actually, when you push the feathers up, it creates ventilation, and then you can flick all the feathers down. There's 250 tiny leaves, and it's all printed in one go. So the peak was taken off and put in the printer above the body of the hat, and it's literally printed within the build space in one go. And that is a completely different way of thinking for product designers. And obviously it's going to have impact on the production line. So to be aware of those capabilities is really key. So moving on from and there's many more characteristics, but those are some of the key ones. If you think about customization or short run, the biggest advantage of additive manufacturing, we all know the hearing aid example, is that you can customize each print. And there's a lovely example here, James Novak, who's a postdoc who works with me. And this is a fingerprint stool that he did, which is based on a fingerprint of his ring finger and his wife's ring finger. And the two are merged to create this stool. So it's completely bespoke to James. And imagine trying to produce anything like that in the last century, which was when I worked in manufacturing, when you really couldn't do anything that was a one-off with any kind of sort of economic viability. I have to point out, though, that this is not a straightforward process. In order to get this right, and in order to be able to do it in a viable way, because it would be extremely expensive if you don't know what you're doing, it took a long time and a lot of practice work to get there. Moving on with the customization is another example from Sam's PhD, working with Materialize, and the fashion designer Melinda Louie is creating a 3D printed dress, which is over 22,000 individual components printed as a single part. We have feat of engineering in itself, and one that you're holding your breath on as the 17-hour print. It happens, and is it going to crash at any minute? But the key thing about this, the reason I'm showing this example, is that it demonstrates that digital communication, associated digital technologies working with additive manufacturing really expands what we can do, and again changes our ideas of what's possible. So this dress, for example, was based on a scan of a model who was in Italy at the time. The information came over to Sam in Australia. The idea came from Melinda in Malaysia. And it was converted by Sam into an STL, which was sent to Materialize in Belgium, where they then printed it, and it's been exhibited around the world. Without digital communication maturing at the same time as additive manufacturing, we really wouldn't have this kind of possibility. So if you're looking at exploiting the capabilities of AM, remember to look around the associated technologies that come with it. But again, thinking about the implications of that for business practice, it really will change a business practice. If you're going to use additive manufacturing, what I would ask you, though, is to not look at replicating existing products. Is to look at how you can exploit the characteristics, understanding them well enough as a product designer, or in this case as an architect, in order to change the potential of what it is we can produce. This is me on holiday. Most people go to the beach or skiing. I chose to go to the Canal House in Amsterdam because it's very, very exciting. And that's me there just being thrilled by seeing the biggest FDM that I'd seen. The work here is lovely, and it's really worth looking at, because what it demonstrates is a new way of thinking about construction, so that the walls of the fabric of the building itself can be bespokely modeled in order to manage water, in order to manage thermal mass, in order to respond to the landscape in a way that's simply not possible with conventional construction, and certainly not viable. So this is a really good demonstration of that kind of change in thinking that I would urge you to sort of really embrace and really explore if you're looking to move to end-use products. Too much of the time, I see examples of products where they're literally looking at something that already exists and then 3D printing it. Now, there are circumstances where that matters, and we're going to talk about one in a moment. But fundamentally, if you're thinking about 3D printing for products for end use, it's about that rethinking of what's possible right down to its very core. So back to that question, is it worth doing? Is it worth doing? Only if it can't be made with conventional manufacturing, and only if it exploits the characteristics and opportunities of additive manufacturing to add value sufficient to make technology viable. Because at the moment, you know, it needs to have that value added to make the technology viable. And I would expect that's going to be the case for quite some time. So that's what it's like if you're in a business, if you're a product designer looking at the products, or if you're, you know, a CEO and you're faced with a situation where someone says, which do you think is the best design for additive manufacturing, or which proposal would you promote? Those are the kind of things to look for. And certainly what I always say to my students. But the next thing is it worth doing it for your business? So in your business situation, and each business is individual in this case, far more than used to be, certainly when I was working in manufacturing, in that this is not just an additional technology. This is not like just adding rotational molding into your production practice. It really will change practice if you use it properly. And so in order to decide whether it's to justify the investment, and trust me, the investment is considerable, the cost of the machines, depending what you're getting, can be very high. The installation of machinery, particularly like metal printers, can be challenging. I can attest to that. And then the maintenance and the effective running of a machine depends on having really good qualified technicians who understand the machine, and having product designers who really understand the machine, because it's not just a case of switching it on and running it. You really have to understand how to work with it in order to optimize practice. Design for additive manufacturing is critical beyond topology optimization, and that understanding of the impact on your business is also really critical. So we're just going to look at 3 little examples here that sort of give you some indication of perhaps how you might start and where you might go to. So one of the things that I would always suggest for a company at the moment is to look at critical parts. This actually was highlighted last year in Australia when we had problems with supply. You know, essentially our supplies from overseas were drastically reduced. So I think of critical parts from 2 points of view. One is your production line itself. Is there anything that if on a conveyor belt there was something that could break down, and if it did, everything would grind to a halt? Is there some kind of critical part that really you need to make sure that you can manufacture locally as a temporary stopgap? And then the other thing to think about is your inventory. Again, is there a critical part that if the supply of that was somehow interrupted, you wouldn't be able to continue with your business? This example here is from Oxfam. I was working with a team. We took a team into Oxfam in Africa to work with the WASH project. Perfect example there, because they would order their parts and they would take 12 weeks because of the humanitarian logistics chains that are in place for very good reason. It would take 12 weeks from when parts were ordered to arrive in East Africa. The problem with that is if a part arrived cracked or broken or missing, or if there was some peculiar geology that they had to work with, they were really stuck, and the people on the ground were going to the local markets and trying to cobble something together. But we had to design these parts for 3D printing. It's not enough to just scan their inventory and decide which are the critical parts and then replicate them. They have to be redesigned for 3D printing. And then, of course, they have to be validated. So this is something that I would strongly recommend that you really do in advance. And it's a good starting point because it's kind of outside your normal practice, and it gives everyone a bit of a chance to build their knowledge on the technology itself. The second approach is Agile Manufacturing. And in this, what I'm saying is that if you're a company and you're not using end-use products at the moment and you're thinking about it, looking at an Agile Manufacturing solution is a good way to explore it, and it's kind of a good way to introduce it into the factory and to get everybody on board and to build those skills and knowledge and to see what kind of printer that you want. So there's a couple of fantastic examples here. One is doing inserts for short runs in injection molding, so it enables you to respond quickly to market needs. It enables you to do short run iterative development with the market. And then the other one here is from Michelin, who are one of my favorite companies in the work that they're doing in this area. I love the more advanced work that they've done. It's fantastic. This was actually done in 2013, and it's tooling that's really complex. It could only be created using additive manufacturing, but it changes how a tire wears down so that as it wears, it improves its grip rather than completely losing its grip. This has been on their trucking production line since, for over 5 years, and it's a fantastic example. Again, it's not as disruptive to practice as going straight to end-use products. This ability to create short runs or to create one-off pieces viably in a variety of materials, and particularly if you're using a service provider. And one of the things about 3D printing is that we have some excellent service providers emerging both locally and internationally that you can use whilst you really sort of build that understanding of the industrial level machines. And if you think about metal printers and the cost of them, I really would recommend that approach to start with. But it does mean as well that you can be entrepreneurial about this. And I don't know a product designer who doesn't harbor aspirations for entrepreneurship. So I've just got a couple of examples of practice here. Again, James, this 3D printed helmet, which is responsive to what's happening in your body while you're cycling, is currently it was currently on tour as part of an exhibition in Europe, but I suspect it's stopped somewhere. But it's a lovely example of being able to do something one-off as an end-use product as an entrepreneur. The other one by David Haggerty, excellent designer. You saw earlier one of his first-year projects. This was his third-year project, which was exploring the use of additive manufacturing either as for direct printing or, as in this case, for lost wax casting. And he was able to produce the files that he could actually send the file overseas to customers who could then have it printed in their country. So it really opens up the possibilities for entrepreneurial practice in ways that were just not possible before. However, today we're really focusing on businesses and where we should go as a business. So what kind of things you should look on as starting points. So if you're going to go into end-use products, the key is value adding. You really need to focus on value adding and what that means because of the significance of the investment. And so you can use, for example, lightweighting, and you can use the consolidation of parts. And this is a lovely example by the wonderful Olaf Diegel. If you're not familiar with his work, please do look it up, and with Atlas Copco. And as you can see here, it's very much, again, reversing how we would normally think as product designers. where we always think in components, and we always think about access, how the tool is going to get in and make cuts, or if we're thinking about injection molding, obviously we've got to think about how the mold comes apart. So here you can literally design the optimum pathway for your particular product, your particular part, and then design the rest of the part around it. And this is a fantastic example. But the reason this is such a good example is not just because it demonstrates the weight reduction. And this is where I would strongly recommend that, you have to encourage your design engineers, or if you are an engineer, to move beyond topology optimization, because you really need to understand design for additive manufacturing as well. Again, this is an excellent example because you've got to understand the heat stresses, you've got to understand how the support structure, the anchoring to the plate happens. And like in this example, the idea of incorporating support structures into the part itself and the design detailing in here to reduce the need for support structure is a, I say, really good example of practice. And anybody who's had hands-on experiences with metal printing and removing support structure afterwards will know how critical even reducing any support structure that has to be removed after printing really is. One of the other key things, if you're looking for end-use products in your business, that you really need to get your head around as a product designer is lattice structures. Lattice structures are a key characteristics of additive manufacturing, and being able to manipulate them and use them to good effect is really critical. Asar Swash is one of my favorite designers. He's an industrial designer, and again, have a look at his website. His work is excellent. This is from many years ago. He really has always been a leader in the field for product design. For product designers, he really is one of the gurus. And with this particular stool, he demonstrates it, how you can use lattice structures to change the characteristics within a product itself, within a single part. And think how amazing that is. Think what the implications of that are. But also think of that from a professional development point of view, or from an academic point of view, is how we teach design for additive manufacturing. We really have to rethink how we think of products. If you can alter the performance characteristics within a single part, then that's radically going to change what you can do and how you can do it, and the kind of end results that you get and the kind of performance. So this is what we need to focus on in academia and actually in professional development as well, to make sure that product design and not just engineering and medical really are up to speed with additive manufacturing, can use it effectively. And part of that is design for process. One of the reasons I think that additive manufacturing doesn't get adopted as quickly as perhaps it could is because that's a complex landscape. Anyone who's attended any of Terry Waller's talks at Rapid, you talk about the different processes and the different things that are emerging and the different opportunities. You're very well aware of the wide range of processes that there are, and the 7 families really of additive manufacturing processes. So when I'm teaching my students, this is third-year student Adrian McCormack, who's an undergraduate. He wanted to, well, it was for a client. It was actually for a blues festival in Australia. He was designing a guitar, and he had to redesign it differently. The white one is for selective laser sintering, and then the red and white one is for fused deposition modeling, or fused filament fabrication, as it's now known. And they were very different designs. Although the outcome is similar, they were actually extremely different. So as a product designer, you really have to know your process. And if you're starting, I would strongly recommend looking at things like the SLS or like the HP that allow you to a bit more freedom. But essentially, you're going to have to learn how different the design process is for those different manufacturing technologies. And that's a challenge. It's no wonder people are a little bit wary of introducing it into their company as a product designer if you're sort of unsure about the range and how to design for the different ones. As a CEO, the implications are huge if you really embrace additive manufacturing properly. And the example I wanted to show you really was from GE Additive, and they've come out with some fantastic examples that really do explain to us the implications. This one is their advanced turboprop engine. And as you can see here, they printed 855 parts were consolidated into 12. And Chris from Additive, who was the project leader for this, was saying they could have actually made it less, but 12 was the optimum because it allowed them to change parts that were likely to wear out. So it was really optimally designed. It had a 5% weight reduction, a 20% fuel burn reduction, and it reduced the critical combustor test schedule. So looking at it in isolation, it's an amazing example, and it's very illustrative of the potential of additive manufacturing. But the key point that Chris explained really was unanticipated. He hadn't anticipated, he knew there'd be some impact, but he hadn't actually anticipated the significance of the impact on business practice. And this is why, to me, whenever we're talking about products, engineering, yes, I teach in an engineering school, and obviously the engineering is critical, but you really have to have the business, business guys in there too, and we have to teach into business schools in order to ensure that these things are really developed with some understanding. Because as you can see here, 300 files to 1, 60 engineers to 8, 50 manufacturing sources to 1. You think about that, the inspection systems are now reduced, the repair sources, just the whole supply chain, the data systems, instead of 40, we've got 1. The whole supply chain was contracted and the whole nature of it changed. This is not something that you can introduce into your company lightly. But in terms of the future and how we can maximize our resources, this really is critical to additive manufacturing adoption. My last comment here really is about sector change. So it's not just businesses. So it's not just product designers. It's not just businesses and business practice. It's actually about sector innovation. So this wonderful example, again, I'm showing an Australian example because I am biased, but Paul D'Urso really is the world leader in my mind on anything to do with this. And this example here, this 3D printed rib cage, which went into a patient in Spain, demonstrates that sector change, because not only is it bespoke to the individual patient, but also it's planned well ahead of time. This thing is, any sort of implants, or I'm not talking about hip implants, I'm talking about bespoke things. If you've got a particular specific issue that has to be dealt with, and in the past you'd open up the patient and then have a whole range of tools that you can use to try and fabricate a suitable fixtures for inside surgery. Now, all this can be done well in advance using accurate 3D printed anatomical models, using surgical implements that are designed bespoke to the actual surgery and based on surgical guides. Now, that means you have reduced time in theatre, reduced costs of the actual theatre. You don't have to sort of create a whole smorgasbord of parts ready to go into the patient. It really changes practice, but it also changes practice, you think, in terms of like telehealth or anything like that, because if we're going to supply the surgical guides and we're going to supply the anatomical models and the surgical implements and everything's bespoke, it can have implications in the future of who can do particular surgeries and how we train surgeons, or we train maybe a new emerging a type of surgeon who is specific to this sort of digital technology. So from a sector change consideration, additive manufacturing really is an exciting technology, and one I think that we should take far more seriously than we appear to be at the moment. So just in summary, what product choices for you, for your business, are more likely to be worth doing. And that's what I would say to you at the moment is going through the slides. If you have a look at it again, it's thinking about from a product design point of view, could it be made any other way? If it couldn't, does it exploit the characteristics of the technology? From a business point of view, will it disrupt your workforce? Is there a way that you can ramp it in by working through critical parts? Or there are other things like ergonomic jigs is another really good way of bringing it into your production line and building that body of knowledge and acceptance. Then you can look at moving into end-use products once you've got that kind of body of knowledge there. But the implications for end-use products, particularly as a CEO, or if you're a product designer recommending it, is that you really have to understand the implications for business and for business practice. For governments and for academia, we need to be thinking about transformation and transition and sector change and the implications of additive manufacturing for that. It's a lot to learn, it's a lot to take in, but it's a whole new world, and I think it's absolutely worth it. And I would seriously recommend to you that you give it a go. Thank you.